So today we will be continuing with the Panda series. Yeah, so first you can see I have defined an email, assign it a value. Now here we are mostly going to do string operations. Like there are various different methods on string which you can do. These methods are also present in different programming languages, so it would be pretty quick. Like you have the split method, and we are splitting it by at the rate symbol, so it converts it into an array or a list. And so at the zero index you have Jose, and at the first index you have email.com. Then I'm getting creating a pandas data frame. So I'm assigning some string values, and I'm printing those values next. Now next I need to convert those values to uppercase, so I would do names.str.upper, again printing out names. Then I'm checking if the email variable is digit or not, so it is saying false. Then I'm checking the names and then converting into a string, and then checking if they are digits or not. Then the last one is true because it was 5, I guess. Yeah. Next I'm assigning a list to tech finance. So here you can see that I have like Google, Apple and Amazon in one. I think that is the first element, and Japan, I don't know, BAC and GS as the second element. JPM, sorry, not Japan. I don't know what the company name stands for. Company short form stands for what is the exact company name. Sorry about that. But I'm calculating the length of tech finance, and it is 2. Then I'm again creating a pandas data frame of tech finance. So here you can see the first one is Google, Apple and Amazon. Second one is JPM, BAC and GS. Then I want to split it by comma, so this all these elements would get converted into list. Then I'm assigning it to tech, Google, Apple, Amazon, splitting it by comma, and then taking out the first element, so it would be Google. Then tickers.str.split, expand of true, it would convert it into a proper table like a data frame. So yeah. Then I'm taking a pandas series again, assigning some values. You can see that Bobo has a semicolon between it, and Claire has a lot of spaces at starting and at the end. I'm then printing these messy names. Then I'm replacing semicolon with an with an empty string. Next I'm replacing semicolon with empty string, as well as stripping means it will strip out the unnecessary space, and then I'm capitalizing it as well. Then here you can see that def clean name, I have created a function, and it does the exact same thing. First it replaces semicolon by empty string, then it strips the trailing and starting spaces, and then it capitalizes, and then I'm returning the name. So here you can call messy names dot apply cleanup. So next we will look into how to use date time. So I'm created my year, my month, my day, my hour, my minute, my second, and I have created my variable called my date. Then there is a date time library, and you can pass my year, my month, my date to it. Same with date time. Here you can using the same thing, but I am passing hour, minutes and seconds as well, so it get converted into a date time object. So once that is converted into a date time, you can just use dot here. It has a lot of functions which you can see. Then I'm applying my series equal to pd dot series. Then I'm see this first date is in some other format, second one is some different format, and third is none. This I'm trying to convert into a date time. So here you can see that it gets automatically converted into a proper date time. Then I'm trying to print the year of the first index. Then obvious euro date, I have taken some date, then converted into a date time, which gets printed something like this. Now here you can see that I am assigning 10 comma 10 dash 12. So in America the first would be the month, but in European nations it would be the day. So I can print sorry, in Asian nations it would be the day. So I'm not sure about Europe or okay, but yeah, but here it treats it as 10 is the month. So by default if you pass it to date time, it will treat it as a month. But suppose you want to tell to date time, okay, don't treat it as month, treat it as day first. So you can pass the day first boolean. Then I'm assigning some fancy date. Then I'm converting that date to a proper date time object, but you can specify the format that first is the day, then there are two dashes, then again there would be the month, but I'm not sure why we have b as the you know per month and dash dash per set year. Then it gets automatically converted to date time object. Now I have a custom date, 12th of December 2000. Now I'm converting that to a date time object, it gets automatically converted. Then I'm reading a CSV file and convert it into a data frame. So here you can see something like this. I'm printing the date column, then I'm converting the date column into a date time and assigning it back to the date column. So now this would be a date time object. So I'm printing the first index, so you can see the timestamp here. I'm printing the year, you can see the year as well. I'm printing the first five columns, first five rows, sorry. So I'm using the head, and again I'm reading it, and parse dates equal to 0, and then I'm printing the date. So I'm not exactly sure what difference it does, but I think what parse dates does is that it automatically converts like datetime into a datetime object, and we are specifying that it is the first column. Then I'm printing out the sales, then I'm setting date as the index, and resample rule equal to a. I'm not really sure what it means, but I'm printing out the sales. Sales equal to pd dot read csv. Then again I'm reading, converting all the dates to a datetime object. Then I'm printing out the year from the datetime dot year, then datetime dot month. Here pwd means present working directory, ls means list all the files which are present in my present working directory, which you can see over here. Import os, it would just like I'm just import os, and then I'm need to get the current working directory, which again prints out content. Then I'm reading csv. Okay, then I'm reading the csv, but I don't want this header abcd, so I'm saying at header as none, so the abcd gets converted into a data. Then if you want to save this data to a csv, you can do df dot to csv to my csv. You can see my csv is printed and index equal to true. But in some case like it depends on how big your data frame is. So if your data frame is big, creation of this my csv file may take a lot of time, and unfortunately there is no progress bar to tell you how much time is still left in creating a csv file. Same over here. Now I am reading some data, printing it back. Then I have a url, I'm reading it as an html and so in this particular url it will scan through the html for this particular url, and only it will take out the tables, html tables. So you might know the table tag, so it will only give you those tables. So here you can see again this is not in proper format. So if I check the length of all the tables, so there are 24 tables. If I print the first table, then you can see something like this. If I print the second table, I have something like this. If okay, I'm assigning the second table to a world top 10, and world top 10 dot drop level, so I'm dropping this column. because it does not make any sense. Next I want to drop the hash column, so access would be 1 because you are dropping a column. Then I'm again printing it out. One top 10 dot columns, I'm assigning some values as columns to it. So country 200 to 15, so you can see country 200 to 15 and so on. I'm printing out table 6, that is table number 7. Then I'm converting it to a 2 HTML file. Then I'm reading some Excel file, and I'm passing the sheet name as well, so I want to read the first sheet of that Excel file. This would be, the data would be something like this. Then I want to create an Excel file, so pd.excel file. Okay, and then wd.sheet names, like whatever sheets are present in that Excel file. Then I'm reading again an Excel file, the Excel file name, sheet name none, so it would give me the dictionary, and we only have one sheet, that is first sheet, so it would print first sheet and all its data in dictionary format, or in hash map. It is in Java it is called hash map. Then you are defining the type, so here you can see it is dictionary. Then that dictionary dot keys, so it only has one keys, first sheet. Then our df equal to Excel sheet dictionary first sheet, that is the we would get the value of the first sheet key. Then that is getting converted to an Excel, so example2.xls sheet name first name dot index false. Okay, I think I said something wrong here. Yeah, I am not, I think this only reads data from an Excel file, I guess. No, for reading data you have to do something like this. I'm not sure what exactly is this. Maybe it copies Excel, I guess. Then coming back to SQL Alchemy, from SQL Alchemy is kind of like a ORM library for Python. I'm importing create engine from it, and the create engine will create a SQLite database. So SQLite is present along with Python, so you don't have to install anything else. You can do the same thing for Postgres and SQL, MySQL, Microsoft SQL, etc. You can check out SQL Alchemist documentation for it. Assigning it value to temp.db, then pt.data frame, data.np.random.randint, low to high size. I'm creating some kind of a data over here. Then I'm assigning this data to this, so I'm creating a new table, but at the same time I'm assigning this value to that table as well, and I'm specifying the connection string. Here in this case I'm reading the SQL, reading data from SQL. You can also pass a SQL query, so I'm just passing a SQL query over here. In this case I'm again reading a CSV back. Now what we are trying to do is that we are trying to find out what are purchases Google has made, like Google, its licenses and sale price only for Google. So I will just find out company, product and licenses. So only this company, product, licenses, not sales price, sorry, company, product and licenses. Then we are pivoting a table. Like pivoting of table, I found it a little difficult, like even I was not sure what exactly was happening. Yeah, but I guess over the period of time we might know it better in the future. So pd.pivot data equal to licenses, index equal to company because you want to find out about Google, then columns are product and values as license. So here you can see company, column is product, values license. Like even I'm not sure why license is not over here, sorry about that. Then I'm pd.pivot table df index of column aggregate function of sum. So it would do the summation of all the pending columns, account number, licenses, and sale price. Df dot group by company, then we are doing sum. I think it is same as the above. And pd dot pivot table df index of a company, aggregate function of sum, but we only want two columns, like that is license and sale price. And pd dot pivot table df index of account manager and contact, and in the values you only want sales price, so only sales price would be displayed. And we were obviously doing an aggregation function of sum, same as the above, but here we are also specifying columns of product. So I'm not really sure. So this is the sales price, I guess. Products, analytics, GP production tracking. I guess it is sum. So some of the string data cannot be summation. We cannot do addition on some of the string data. Some string data columns. I think that's why it is missing data for some of the columns. Then TF index account manager contact values of sales price column products aggregate fill value 0. So in case there is null value is not present, we are filling it with 0. Then margins equal to true. This will just add margins to your table. Yeah, that's it for today's video. Thank you for watching. See you in the next one.